Hello everyone, welcome to our video. We are group 8 of division Q and today we'll be discussing the topic of microprogrammed control units and microinstructions. Now before we dive into this topic, let us introduce ourselves to you. First up we have Kedar Sate, roll number 42. Next we have Srushti Sate, roll number 43. Then we have Sankalp Savne, myself, roll number 44. Followed by Savi Gaikwad, roll number 45. And finally we have Arya Savne, roll number 46. So let's start with the question, what are microprogrammed control units and microinstructions? Microprogrammed control units and microinstructions are fundamental component of the computer system responsible for coordinating all operations within the computer. In layman's terms, the control unit of a computer can be thought of as a brain of the computer, and the microprogrammed control units and microinstructions are the set of the instructions that allow the brain to direct the computer to perform various tasks. So in conclusion, microprogrammed control units and microinstructions play a crucial role in ensuring the smooth operation of the computer system. We hope this video provides you with a comprehensive understanding of the topic and the importance of the microprogrammed control units and microinstructions in computer system. Before you delve into the depth of this topic, it is important to lay the foundation by understanding some essential terminologies. Having a clear understanding of these basic concepts would allow us to fully grasp and comprehend this topic. First up, we have the control unit or CU. It is a key component of a computer central processing unit, also known as the CPU. It is the responsible for executing instructions. The control unit retrieves the instructions from the memory, decodes them into control signal, and then sends these signals into appropriate parts of the computer to execute the instruction. Next up, we have the decode execute cycle. It is the basic operational sequence that the control unit follows to execute instructions. Now, this cycle mainly consists of two steps. First one, the decoding the instructions, and second is the executing instruction. It is as simple as that. Next up, we have the instruction set architecture or ISA. It is the set of instructions that a computer CPU can execute. ISA is critical to operation of the computer as it defines the basic operations that the CPU can perform. There are several standardized ISAs such as x86 ISA for personal computer and ARM ISA for mobile devices that allow for compatibility and interoperability between the different computer systems. Next up, we have the instruction register or IRs. It is a register in the control unit that stores instruction to be executed. The control unit retrieves the instruction from memory and stores in the IR, where it is decoded and executed. The IR is an important component of the control unit as it acts as a temporary storage location for the instruction to be executed. Now, finally, we have the microcode. It is a type of low-level machine code that is used to control the operation of the control unit. Microcode is stored in read-only memory ROM and provides a more detailed set of instructions for the control unit to execute. Microcode is used to implement the ISA and provides a more flexible and efficient way of controlling the operation of the control unit.
Steps followed by microprogrammed control. It can execute any instruction. The CPU should divide it into set of operations which are called microinstructions. These sequential micro-operations need control signals to execute. Control signals which are saved in ROM execute the instructions on data direction. They control micro-operation concerned with the micro-instruction that is to be performed. The address of micro-instruction that is to be executed next is generated. The previous two steps are copied until all micro-instructions are executed.
Hi guys, I'm Kedar Sati. Today we are going to discuss the block diagram of microprogram unit controls. As you can see in this block diagram, the microprogram control unit of the basic computer consists of several components. Let's go through each of them. So the first component is the external input. This is where the input data is fed into the computer. The next component is the next address generator or sequencer. This component generates the next address for the control memory. The next component is the control address register. This component holds the current address of the control memory. Next is the control memory or ROM is the component that stores the micro instructions. These micro instructions are executed by the control unit to perform the various operations of the computer. The next address information component is used to store the next address information. This information is used to determine the next address of the control memory. The next is control word component. The control word component is used to store the control word. The control word is used to control the operations of the computer. The last component is the control data register. This component holds the control data that is used by control unit to perform the operation of the computer.
Hello everyone, we'll be discussing the advantages of microprogram control unit. A microprogram control unit is a type of computer control unit that uses microinstructions to execute control functions. In this part, we'll take a closer look at the benefits of using microinstructions in a control unit. First, systematic design of control unit. One of the biggest advantages of microprogram control unit is that it allows for a more systematic and organized design of a control unit. Microinstructions provide a structured and standardized way of expressing the control function, which make it easier to understand and modify design in the future. Second, simplicity in debugging and change. Another benefit of using microinstructions is that they are typically easier to read and write than machine level instructions. This makes it easier to identify and correct errors in the control unit. Additionally, changes to control functions can be made more quickly and easily, as they can be made at higher level of abstraction. Retaining the structure of control function. By using microinstruction, the underlying structure of control function can be preserved. This makes it easier to understand and modify the control unit in the future, which can save time and resources. Orderly and systematic design processes. The structured nature of microinstructions allows for an orderly and systematic design processes, making it easier to manage and track changes to control unit over time. This helps ensure that design processes remains efficient and effective. The microprogram control unit is a type of control unit that uses microinstructions to control the operations of a computer. However, there are some disadvantages associated with the microprogram control unit, including slow operation. One of the main disadvantages of microprogram control unit is that it operates slower as compared to hardwired control unit. This is because microprogram control unit relies on a series of microinstructions that must be executed one by one, whereas hardwired control unit can execute multiple operations in parallel. And increased cost of adaptability. Another disadvantage of microprogram control unit is that the adaptability is often at higher cost. Changing the operations of microprogram control unit requires modifications of microinstruction, which can be time consuming and expensive process. Thank you.